Hi, I'm Melissa with the ShookIOT products team. Today we're going to take a look at ShookIOT Downtime Tracker. Downtime reporting is the first step towards predictive maintenance of your equipment, allowing you to move towards diagnostics and servicing, asset and supply management, before heading towards predictive maintenance itself. It allows you to identify when your equipment is down, and more importantly, why it is down. By understanding your equipment performance and the root cause of failure, you can make decisions that are informed by data instead of by gut feel and past performance of equipment. Let's start with an example of one of our textile manufacturing clients and the downtime status dashboard. Here you can see a list of all the equipment that is currently being tracked at a plant. We've got 2 laminators and 12 looms at our textile plant, and they seem to be making a variety of different colored fabrics of different widths. Some machines are running, some are sitting idle, and some have an error that an operator should be addressing as soon as possible. The system is able to differentiate between the different asset types and understands the unique types of downtime that might exist for a given asset type. The looms have warp breaks, where the long threads under tension might have broken. But the laminator, that is affixing a reflective stripe to the material, has tripped a temperature high sensor, and this means the laminator might ruin the final product or even present a hazard in the plant and needs to be shut down. The dashboard updates automatically, and because it runs in a web browser, the accessibility for operators and plant managers is almost unlimited. Monitors can be mounted on the walls of the manufacturing floor to give operators a high-level overview of which machines are running. Operators could monitor the status from handheld tablets or phones, and regardless of which method is chosen, operators instantly know which assets require attention. By knowing which machines are down, and more importantly, why they're down before an operator walks over to a machine, they can better plan their maintenance schedule and reduce time to repair. I've created a simulated device that sends the exact same signals as the looms running at our customer site, and I can use this simulated device to send a warp event from one of the looms. The status page refreshes, and we can see that the loom is now in warp break. From this data, we can identify how often a warp break occurs, and the average time it takes to repair. I'm clicking on refresh manually, but in production this report refreshes automatically on a 1-minute timer. On the dashboard, we can click on an asset and see the list of all the downtime events that have occurred for that specific piece of equipment. This one has a few different thread breaks. I've got a warp event and a weft event. It's running for a lot of the time, and sometimes it's sitting idle. This is where we get to engage the operators. Their primary role is to run the equipment and produce the textile product. These intelligent people know things a sensor can't. The operators are aware of production schedules, past performance of the looms, and recent maintenance. While these looms are able to detect an equipment fault, like a weft break or a warp break, it's impossible for the loom to know that it's down for scheduled maintenance. It might be sitting idle because there aren't sufficient orders to fill, and the warehouse just doesn't have room for that extra inventory should it be running. This is why we need to engage the operators. An operator comes into the system, selects one of these system idle events, and selects a downtime reason. Let's put Loom 2 into scheduled maintenance. If there's a downtime reason that isn't in the list, we can also pick Other and add it manually. For asset performance management, this is the whole point of downtime tracking. It generates downtime by cause that is validated at the source. This is the highest quality of data, and the data can be used for everything from reporting to Pareto analysis to machine learning modeling of downtime precursors and downtime prediction. With a Pareto analysis, you look at many possible causes of action and estimate the benefit delivered by each action. With machine learning, we can analyze the process data around the downtime events, identify correlations, and ultimately predict a downtime event before it occurs. Let's take a look at a report. This is a sample downtime tracker report that we put together in Microsoft Power BI. Here we can see all of the looms and how they've performed over the past week. For a given day, we can see the breakdown of a loom by all the different status codes. We can identify the number of times an event has occurred for a given asset and how long it is spent in that downtime state. We can even report based upon product SKUs. Some products might be more susceptible to breaks just due to the difference in raw material composition or supplier. Downtime Tracker highlights each of these situations. Adding new assets to the system is super easy. ShookIOT Downtime Tracker is powered by our ShookIOT Fusion Cloud Historian model. The Fusion model stores a digital representation of all the physical industrial things found at a plant, from individual assets like looms to locations such as the weaving room or even entire buildings. It also stores the relationships between these things and all of their properties, from physical specifications to sensor measurements. Here we see the whole textile plant, from the weaving room to the finishing room and some of the assets located in each room. I'm going to show you how easy it is to bring Loom 13 online and add it to our downtime tracker system. We add a new loom, name it Loom 13, and then once it's created, we can look at the specifics about this loom. ShookIOT Fusion stores the raw events in our historian database, so we need to specify the tag name that corresponds to the sensor reporting the downtime status. Inside Fusion, we can also add other specifications, such as order number. By adding a new specification, this value is automatically associated with each new downtime event. In our report, we were able to view downtime events per asset and per production SKU. This would allow the report to also filter on order number that is being filled. For our looms, we're using an IoT device that is mounted on the side of the loom. Our simulated device has a picture of an actual loom running the ShookIOT Downtime Tracker. This gray box mounted to the side of the machine detects and reports downtime status directly to the Microsoft Azure cloud. Your devices might have a status tag, but even if you don't, Downtime Tracker can help. Our downtime event detection and analysis algorithms can detect downtime events based upon other production values. A flow rate on a pump dropping below a certain threshold could trigger a downtime event. So now that we've added Loom 13 to our Fusion model, let's turn Loom 13 on and get it sending data. My simulated device is capable of sending the run signal to Downtime Tracker. The status page refreshes, and Loom 13 appears automatically. No configuration required. ShookIOT Downtime Tracker makes gathering and analyzing downtime events easy. You can view your reports from anywhere in the world, and the system can be configured to send notifications via email, text message, or even by sending out a tweet or Slack message. The dashboard is intuitive and responsive and engages operators into capturing downtime data. Thank you for watching. If you would like to learn more about how ShookIOT can help you start capturing downtime event data, please visit us online at www.shookiot.com. If you'd like to learn more about the textile company we partnered with to make Downtime Tracker, please check out our Davey Textile Solutions success story video. You can also watch some of our other videos, and please like and subscribe to stay up to date with all the exciting things happening at ShookIOT.